Hey folks, I'm going to take you through a couple examples from assignment 1 and assignment 2 because these can be kind of tricky and confusing. Okay, so you need to have your periodic table. You need to have assignment 1, which is page 9. So we're going to work through this chart, finding information, figuring things out about atoms and ions. Here we go. Let me just get, let me get my pen mode going. Okay, here. Okay, so we're starting out with fluorine. Is fluorine a metal or a nonmetal? Well, you can find it on the right side of your periodic table, so you know that it is a non-metal. Okay. The Lewis dot structure as an atom. So we want to draw the Lewis dot diagram for an atom of fluorine. Okay, so we draw an F for fluorine, then we look on our periodic table to see, its electron configuration is 2-7. That means 7 electrons in the valence shell. Lewis dot diagrams just show the valence electrons, so we start with 1, 2, 3, 4, 5, 6, 7. Okay, so the atom has 7 valence electrons. It's not stable. It would really like to have 8 valence electrons because 8 is great, so it is going to gain 1 electron to get 8. The easiest thing to do is to gain 1 electron rather than losing 7. Now it's stable, but we need to draw the Lewis dot diagram of the ion. So we have added 1 electron, we've gained 1 electron, so we draw our fluorine. We draw some nice big brackets around it because ion dot diagrams always have brackets. And now it has 8 electrons, and I'm going to just draw them in any order because I know I'm going to do all 8. And we need to know what charge. Well, if we gained 1 electron, that means it went from having a neutral charge, like an atom, to having a -1 charge. You might draw that 1 minus or -1. And now it becomes like a noble gas. It went from a 2-7 to an electron configuration of 2-8. And what noble gas has 2-8 for its electron configuration? Well, neon does. Okay, that's an example for assignment 1, and you can work your way through the rest of these and then check the answer key. Assignment 2 is a little more tricky. I'm going to do 2 questions out of assignment 2. Here we go, and assignment 2 is, let's go, okay, on page 10. This is definitely tricky because of the charge column. Some of the things in this chart are atoms, some of them are ions, so you have to watch yourself. Okay, here we go. In all charts like this, you look for the clues that help you fill in the missing information. And right here, the first important thing that you can find that'll help you is the number of protons, because that's the atomic number. So with 20 protons, we must be talking about good old calcium. You can find it on your periodic table. Atomic number is 20. And then this column should actually say mass number, not atomic mass. That's a little bit confusing. Okay, but mass number. So since the mass number is 40, put that up here in this atomic symbol notation. And the number of neutrons, well, 40 minus 20, number of neutrons is 20. 40 minus 20 equals 20. Now you might think, I can fill in the electrons because it has 20 protons, it must have 20 electrons. But wait, this is a charged particle. This is an ion. So the number of electrons may be different. How do we figure out how many electrons there are? We go just like this. In this column right here, we're going to add a little bit of extra information. Calcium starts out with an electron configuration of 2-8-8-2. Okay? But then this says it has a charge of +2. That means it must lose 2 electrons to now have more positive charges than negative charges. So it loses 2 electrons. Okay? So now it has an electron configuration of 2-8-8. Now it's stable. It's lost those annoying 2 little electrons that are hanging out there, and it's lost 2 electrons, so it has a +2 charge. So how many electrons does it have? Well, we could count the electron configuration. 2 electrons plus 8 electrons is 10, plus 8 electrons is 18. Okay? Another way to figure that out would be to say, okay, well, originally it had 20 protons and 20 electrons. It now has a charge of 2+, so that means it's lost 2 electrons, so it has 2 more protons than electrons. 20 is 2 more than 18. How many valence electrons? Well, now it's lost 1 whole shell, but it's down to having 8 valence electrons like a noble gas. The Lewis dot structure of the ion, okay? The Lewis dot structure of the ion is going to be, well, let's see. It was calcium. It lost the 2 electrons that it had on its outer shell. So we just draw calcium inside the brackets and we put the charge. Why don't we draw any dots? Because the dot diagram shows the original valence shell. The original valence shell had 2, and now the original valence shell has 0. So the Lewis dot diagram always shows the original valence shell. Yes, in its new valence shell, which is 1 shell lower, it has 8 valence electrons. But this diagram is showing what was in the original valence shell, showing us that it lost 2 electrons. Okay, let's move down to the 3rd row from the bottom and try this one, starting with 8 protons. 8 protons means, it must be our good old friend oxygen with an atomic number of 8 and a mass number of 16, which it gives you right here. Okay, 16 minus 8 means we have 8 neutrons. Okay, now our charge of minus 2 is going to affect the number of electrons over here. So let's figure this out and see what the number of electrons would be. Originally, oxygen as an atom had an electron configuration of 2-6. Okay, now it has a charge of 2-. That means it gained 2 electrons. Okay, and so that means it now has a structure that is stable. It's got a stable octet with 8 electrons in the valence shell and 2 in the first shell. So now, originally oxygen had 8 protons and so 8 electrons. Now it's gained 2 electrons, or you can just count here, 1, 2 plus 8, that's 10 electrons. Okay, the number of valence electrons, well, in that same shell it has 8 valence electrons. Okay, and so our Lewis dot diagram of the ion, we show oxygen in brackets. Its original shell had 6, now the original shell has 8, so we draw 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons in its original shell, and it has a 2- charge. Okay, there now you have 2 examples from this page. Do the rest the same way. Go in that charge column and fill in the information of what's happening so you don't get messed up on the electrons. And also remember, some of the rows on this page are atoms. When you make a Lewis dot diagram of an atom, it won't have any brackets. The brackets are only for ions. Okay? I hope this helped you with assignment 2.